Good morning, class. Mr. McCray here again, giving you another video. This time we're going to be talking about slope and rate of change. If you had me in math enrichment, you had some preview of this, and basically this is the video for the regular classes. Basically, we're going to talk about slope and rate of change and the different styles and how to actually find that from different ways, from coordinate points to looking at it from the graph and finding it there, also finding from a table, and then finding from a verbal statement. And that's where our focus is going to be on today. Next time in class, we're going to take that information and then we're going to start making equations using the rate of change and vice versa. So please, like I said, try to listen, get the most information you can so we can kind of keep it going as we go along in the process. So first things first, let's look at the top one here. Okay, we have distance on the y side, and we have time on the other side. So we have 2 points, and basically this is a line that represents these 2 points represent that linear line that goes through them. Okay, so basically we have to find the slope of this linear line. So we have 2 points, and basically their coordinate points are 4, 3. Okay, I'm not going to go over how to do that. I think we know how to do that after nauseum. 9, 7. Great. So the determine is, how do we determine the slope? And what is a slope? Slope is basically, how does it change over a period of time? So you want to look at 2 points that are pretty definitive, that are on the like the box corner of the boxes, and then you want to basically take those and determine to see if the what the rate of change is. Now, sometimes it can be non-proportional, and we'll show, and obviously you saw from that from the regular graph inference that I showed. So they can be non-proportional graphs as well. So be aware. All right. So first thing you want to do is you want to find out, okay, how high does it go to get, and how far to the right does it go to get to this point, from point one to point two. So I want to make a line here that represents the distance, like almost like a right triangle. Okay. So if we look up, how high did it go to get to this point? So we know that this is 7. Okay, and this point right here is 3. So all we have to do is figure out what the difference is, or we can count the boxes. 1, 2, 3, 4. So it would be 4 to get from 3 to 7. If you look on the other side, we have 4 to get to 9. So that would be 5. Okay. And so from there, all we have to do is add labels to this. So we're going up, then we know we have feet is distance. That's feet. Okay. If we're going from this point to the edge, that's going to be minutes or time. Okay. That's going to be minutes. Okay. So that's going to be minutes there. So therefore, the slope would be these two differences put together into a fraction. So you think about it, okay, how high did it go? It went 4 feet, so it's always going to be 4 feet on top. Okay, 4 feet. Okay, and the bottom will be 5 minutes. Okay, and that would be the slope. Okay, 4 feet, 5 minutes. Okay, so therefore, okay, so what is the natural way to determine slope? So again, we talked about slope in terms of a couple ways, okay? We have to figure out what the change in y is. So that's what the little triangle means, the change. So what is the change between 4 and 7? So the difference between that and the change in x. So the difference from where you go from this point all the way to the end, you find the difference of that. So how also they call it is called rise. This is the rise, the y-axis is the rise, over run, which how far does it run to the right or left? Okay. It also could be shown in equation form of y2 minus y1, x2 minus x1. Or it can be switched the opposite way, x1 minus x2, y1 minus x2. So what we're going to focus on today is these two kinds right here, is using these two to actually determine what the rate of change of the slope is, knowing the given coordinate points. Okay, so hopefully you got that information and you can listen and practice on as we go through this process here. All right, so let me move this down a little bit and let's try some problems. Okay, so we have the first one here. We have 12 and 16 and negative 20 and 4. So we basically have two coordinate points, like similar to what we have there, that pass through a linear line, and we have to determine what the slope is of those points. So what I did was I made with the process and I put x1, y1 to represent the first coordinate point, x2 and x2, y2 to represent the second coordinate point. And basically, I'm going to take this portion, this little equation here, and that's going to help me find the slope. So I'm going to take y2, which is 4. I'm going to minus that from y1, which is 16. And then I'm going to take x2, which is negative 20. I'm going to minus that from x1, which is 12. Okay. So 4 minus 16 is what? Is negative 12. Okay. And then we put a parenthesis, and then we have negative 20 minus 12 is negative 32. Okay. So that's how it would look. Now, from the rest of it, I would probably wouldn't leave it to this fraction. I would reduce it. Okay, so I have to reduce this. So the greatest common factor between 4 and 32 is 4. I mean, sorry, 12 and 32 is 4. So I divide both of them by 4. So that's going to give me 3 over 8. Okay, and it's going to be positive because we have two negative numbers here. If we divide them both together, that's going to give us a positive 3/8. So that would be the slope of this equation. Okay, it would be 3 over 8. Okay, so once we get really good at this, we're going to be able to use this slope and basically be able to determine and make the graph out of this. That's like I said before. Okay, so let's do another one. So we basically have x. So we have them all labeled out again. We just basically, I'm going to do it the opposite way. I'm going to do it with the x1. So we can see that it either way works. You just have to put it in the right order. So let me do x. I'm sorry. Whoops. I think I made a mistake here. My fault, guys. This is actually should be, let me erase this. This should be y on the top and x on the bottom. Oh my God. I can't believe I did that. So this should be x, this should be y1 minus y2. And this should be x1 minus x2. My God, jeez. All right, so let me use this and finish this off. Okay, so we have y1, which is 3, okay, minus, okay, y2, which is negative 2. Okay, so remember, you can't just add, you have to add the negative. So it's negative 2, put a parenthesis around it with the negative in the middle. Okay, because that's important. You got to make sure you're minus and minus. Okay, so then we have x1, which is 1 minus 3. Okay, so again, we want to multiply. We want to add again. We have negative and negative. It turns to positive, so that gives us 5. Okay, the 5 could be made. Okay, and that's over negative 2. Okay, so that would be the slope of this equation. Okay, that would be the slope. 5 over negative 2. Okay, and we would leave it like that. We wouldn't actually like reduce that or like divide 5 divided by 2 or 2 divided by 5, and that would give us 2.5. But that's not what we need. We just need the slope to be that and just leave it like that. So the only thing you want to do in this situation is you want to reduce the fraction the lowest you can to the simplest form, but you also want to leave it as a fraction. Do not change it and move it into like a unit rate and finding out per 1 unit. Okay, leave it the way it is. All right, but also if you can reduce it, but then leave it in fraction form. Okay, so that's how you would do it using coordinate points. All right, so let's move on. So we have another situation. We have an actual graph. So now we have to use the graph and use coordinate points to actually find the actual slope. So I already started doing that here on this one. So I took this point and the point on the y-intercept. So a couple things you need to know. The easiest way to do that to find the coordinate points is I would definitely use a y-intercept and possibly an x-intercept. That would be the two easiest ways to do it. But right here, I just use this value, right, this coordinate point here. Okay, so I use negative 4 and 4 because that's the coordinate point here, and then we use 0 and 2. Okay, and that's the other coordinate point. Okay, so this would, again, would be my x1, this would be my y1, this would be my x2, this can be my y2. Okay, let's finish this off. All right, so again, I'm going to start with y2. So it'd be 2 minus 4, okay, this time. And then I'm going to go over, and then I have my x2, which is 0, right? Yeah, 0. And I'm going to have minus 4, because the x1 is negative 4. Okay, so we have 2 minus 4, which gives us negative 2. Okay, and then we have 0, negative 4, so that's it's plus. Okay, and so that just turns to positive 4. Okay, now we have negative 2 over 4, which we can reduce to negative 1. Okay, because we can reduce that to negative 1/2, and we'll leave it like that, and that would be the slope of this line. Okay, negative 1/2. Okay, so this is important stuff to know, but right now we're going to leave it that way. All right, so let's move on here. Let's move on. If you really want to think about it, is this actually true? Is this statement true? Okay, so the slope, if we did the rise, will run again. So we started, and this is negative. So actually, we would go down 2, and then we go over 4 to the right. And so that does make sense. Down 2 on the rise, or the drop, or the rise, down 2, and then over 4 to the right, and that does make sense. So that would be the slope for the situation. All right. So the next portion is, now we have it in tables. So we have to find the slope out of a table here. Okay. So tables is actually kind of easy. Okay. So basically you have to figure out what the change. Remember, the idea is the change in y over the change in x. Okay. So let's look at it. What's the change in y here every time? So if we go from 22 to 4, what are we going? We're going negative 4 here. Okay. Actually, negative 5. Sorry. Dang. Okay. And then we have negative 5 here. And then we also have negative 5 here. Okay. Now, what are we going up? All right. Actually, going from x to each x point. So it looks like we start at negative 2, we end up at 3. So that's 3, right? Okay. And this one we go 3. And this one we go 3. Okay. So that's all we need. So we find out what the change in each one. So again, what's the change in y? Again, it's negative 5. Okay. What's the change in x? 3. And that's it. That's the slope. And that's how it works on the equation. Okay, that's the slope. That's it. It's pretty easy. Okay, so let's look at another one. Okay, this one, same thing. Let's look at the change between each value. Again, you can pick two coordinate points. You can take 10 and 2 and 7 and 7, and you'll get the same exact answer. All right, so I can take the actual coordinate points of 7 and 7 and 10 and 2 and plot them into that little equation I gave you before of xy2 minus y1, x2 over x1, and you get the same answer of negative 5 and 3, because they're all proportional to each other. All right, so let's look at another one. Let's actually do it the other way. So let's use it with the equation. Okay, let's use the equation to figure that out, to show you both ways to do it. All right, so I'm going to pick this coordinate point, and I'm going to actually, you know what, I'm going to pick this one. This one's easier, these two. Okay, so this is x1. This is x2. This is y2. This is y1. All right, so let's do that here. So again, we got y1 minus y2. Let's get x1 minus x2. Okay, I think we get that whole idea. So let's do 3 minus 7. Okay, and then we put that over, which is the other one, which is 1 minus 0. Okay, and so that would give us a value of 3 minus 7, which is negative 4. Again, positive, negative interest, got to know those. And then this is over 1. So that would be the slope, -4/1. And if you think about it, okay, let's see, yeah, y2, y1, x2, yep, that's right. All right, so let's look at it here, all right? Look at this values here. Two, that was exactly how it would work, okay? One. Oh, actually, it just should be negative, sorry. I should flip this, my fault. That's why I wanted to check it. It should be 0 minus 1. Okay, so to give us a positive value of 4/1. Sorry about that, guys. All right, so if we check it, we just have to find the distance. So this is 4. You flip this. This is 4. Okay, that you find the difference here. This is 4. This difference is 1. This difference is 1. This difference is 1. Okay, so that's exactly how it would go. 4/1, and that would be the slope of the answer. The slope. That's pretty easy to do, I think. Okay. Let's try more information and we'll be done for class today. All right, so here's that a verbal statement. Okay, so we have to find the slope of this verbal statement. Okay, again, I'm going really slow. I'm going making this really easy for you guys, so you don't have to do a lot of work at this point. Just trying to go over all the basics because again, you guys have been doing a lot of virtual learning and things like that, so it's kind of hard to make sure that we want to make sure you get all this information because this is important as we build uh, up in ninth grade and vice versa. Okay, so let's look at the value here. So Bob has 40 Skittles. He eats 5 Skittles every 3 minutes. Okay, so 40 Skittles is great. 5 Skittles every 3 minutes. So the idea is okay, we got to determine what's the X and what's the Y. Okay, what's the X? What's the Y in this situation? So we know the X is always going to be the independent variable, and that usually is time, things that all happen independently, that without anything else happening. So if you think about it, in this situation, 3 minutes is time. So that would be our X value, would be 3. The next is, okay, what is outputted every 3 minutes? Okay, what's the output for every 3 minutes? It's 5. Okay, so that would be the amount of Skittles that he eats. So if you think about it in terms of slope, okay, change in y over the change in x. Okay, so that would be, so the y would be 5, and the x would be 3. Right, and that's how it would go in that situation. Okay, that's all you'd have to do. Now we can divide that if we want to, but we don't have to do that. All we want to do is basically take those values. So we have another one. Sarah runs 3 miles every 24 minutes. And she's already ran 5 miles. So that 5 miles is going to be something we're going to need later on. That would technically be the constant. Okay, the constant. All right, so we can make an actual really equation out of the whole thing, but we're not going to get. We're almost there. So Sarah runs 3 miles every 24 minutes. So we know that we need to find an x and we need to find a y. Okay, we know that time is usually going to be the x, okay, because that's always going to be independent, and whatever we output from that time is going to be our y, our dependent. So let's think about, so our x would be 24 minutes and our y would be 3 miles. So again, we just make our equation 3 over 24. So we have miles m, and this would be minutes. All right, okay. So doing that now, okay, now I got 3 over 24 would be my slope, but that is kind of high, so I can also reduce this. So 3 goes into 24 8 times. So again, I'm just going to divide by 3, both top and bottom. So that's going to be 1 minute over, that's going to be 1 mile every 8 minutes. Okay, which is kind of similar to your unit rate. Okay, because you think about it, unit rate is per 1 minute or one per 1 unit of whatever you're actually doing. So this would actually technically be the slope, but it also would be the unit rate as well. So sometimes the slope can be also determined as your unit rate. Okay. But the idea is you basically at this point be able to get the slope of the equation and once you're able to do that, then we can start moving on to harder stuff as we go along in the process. But I appreciate everybody being able to listen. um, get the work done for today of finding slope, and we'll move on to some harder stuff as we go along. Bye now, guys.